So as we are aware, MapReduce is the core processing component in Hadoop. Is it is fully written on Java. So whatever the code it is supportable. So Java is most preferable language for writing the MapReduce application. So why? Because the Hadoop, whatever the Hadoop framework is written on Java only. That's why it gives a better performance if you write that MapReduce application in Java. So it is all about MapReduce. So let me write some definitions here. What is MapReduce first? So as we know, MapReduce is one of the core component of Hadoop, which is meant for processing of huge data sets. Because Hadoop is meant for huge amount of data sets for storing purpose. If we have a small amount of data sets, we can able to store that data into our data warehouse or RDBMS tools anywhere. But whatever the traditional system right now in the market, it is not capable to store the huge amount of data in terms of petabytes, zettabyte, and yettabyte. That's why Hadoop came into picture, and it is processing and also store the huge amount of data sets in a distributed parallel fashion. You can say it's fashion on commodity hardware. Commodity hardware. So what is commodity hardware? Let me explain first. Commodity hardware means it's a very less expensive and it is a very cheap kind of hardware. It's a very cheap kind of hardware that is known as commodity hardware. So we have already discussed with the replications factor and fault tolerance, everything we have discussed. As there, we have seen the commodity hardware, why we are using that. So after this, these are the overall brief description of the MapReduce, like it is a core component of processing tools. So whatever the job we are writing in the MapReduce, it will in MapReduce or in any ETL tools like Hive, Scoop, or Apache Pig, the backbone or the backend or the internal of this job can be break internally into the MapReduce only. So now coming to the different phases of MapReduce. So MapReduce, there are two functions. It is like a map and reduce. This is two functions. What is map and what is reduce? I will tell you later. So these two words combine to each other and make known as MapReduce is a term. So which is known for the for processing tools in Hadoop. So coming to the different phases of MapReduce processing. So what are the different phases we have in MapReduce? So first phase is mapper. Okay, so what is mapper phase? So mapper is known as the transformation. Okay, transformation phase we can say. So what happens here, like I have the input data, so I am getting from the different sources of data. It is not from the local file system. I am getting data from the AWS. I'm getting data from the NFS network file system. I'm getting data that is a source system is also the some RDBMS tools should be there. So that is the input data I'm getting. So before coming when I just means before analyzing that data should be transformed somewhere. So this phase has been driven by the developer only. Developer driven phase we can say. It has been driven by the developer only. It means developer is responsible to write some transformation logic. So he is responsible for that mapper phase. Now after this mapper phase, the second phase come into picture that is short and shuffle. So it is known as the sync phase. Here everything is sync here. So it is not a developer driven phase. It is a framework responsibility. it is a framework responsibility. So in the framework itself, the Hadoop framework itself, all the things is there like how to sort it, how to shuffle. So we will see one of the examples so that we will cover this mapper phase, sort and shuffle. And now coming to the third phase is known as reducer phase, which is known as computation phase. Computation phase, or we can say it's the action phase. So in this phase, the developer who is developing the code, who is writing the code, he is driving this phase. He is responsible to write logic as per requirement, we can say. Okay, so he is responsible to write the logic as per the requirements. So this is the three phases in MapReduce. First is mapper phase, which is also known as transformation phase. It has been driven by the developers only. Second is the short and shuffle phase, which is the sync phase. We can say it has been framework responsibility, not by the developers here. And third one is the reducer phase, so which is a computation phase, or we can say action phase. Here, the developer is also responsible for this phase. The developer is responsible for write the logic here. So like take an example, come to the example like example here. I have one input file. Take an example, input file is abc.txt file is here. I know its size is around 100 MB. Okay, that should be fine. And the data, suppose the data inside that Hadoop is a framework, open source framework we say, and also we can say Hadoop is a solution of big data. So like that, this is the informations we have as a text informations we have. So my requirement is I just want to count means occurrence word. I just want to occurrence word we can say. Occurrence word means repetition of the word. So what will happen? So first, this is the input data come into picture. So at the mapper phase, we are just able to transformations of the data. So I have this data. I need to just transform this data. So how we can transform it? So it's a different logic. So we can say how many times like I have just break all these lines. This is a value. I just break this Hadoop comma one. So I'm just talking about mapper phase. Mapper phase. What happened there? So first the mapper phase come into picture and I just write some logic there. Accordingly, I'm getting the output like this: Hadoop comma one is comma one and like a comma one. So like that I'm getting the breaking all the words and with one value we have given like that. So if coming to the second line, he's also breaking somewhere like Hadoop comma one and it's also is comma one and here a comma one and it's also come like a solution comma one. So like that, okay, and one is the big data we can say. Okay, only one is like so it's a transformations of data. I'm just transforming of data as a just breaking the whole sentence into a words and we can just write one comma one comma one because my requirement is to find the occurrence of words or repetition of words like how many times Hadoop came into picture. So I know this is two times, but how we can write the logic in the Java so that I can get Hadoop with Hadoop is a key and value as a two. So accordingly. So it comes like mapper phase. Now coming to after completion of this mapper phase, the short and shuffle phase come into picture. As you know, you don't have to write any logic here for the short and shuffle. So first it will short. Short means as per the this is a key, this is the value. One more thing, MapReduce works with key comma value pairs. So first should be the key, whatever the values should be there. So as you know, JSON data, Java script object notations, it also has key value pairs, right? Key value pairs. So key value pairs data is there. So like that, I'm not saying it is a JSON data. JSON is very different. It's like a key value pairs. Like that, the data also accepted in Mapreduce as a key comma value pairs pair. So I will tell you how this data I have, it converts to key, and it's what is the value here. So I'm just transformations, we are just seeing the phases. So first transformations has been completed, mapper phase completed. Now coming to short and shuffle. So short and shuffle is the key, is shorts with the key only. So I am saying Hadoop is a framework, Hadoop is a solution of big data. So as per the short, so first I think so this should become first. So in short and shuffle, short and shuffle phase, as per the framework driven is A should become first. Okay, after this, if framework should become second, and I think Hadoop comma 1, and at the moment end movement is comma 1. So this has been shortened, short has been completed. Now coming to shuffle. Shuffle means to aggregations. So like Hadoop 1 here, also Hadoop 1 here. So what it will do, it will come like this. Hadoop is one of the key, and how many times Hadoop come 1 comma 1. Same here, is a key, how many is come 1 comma 1. So like that this has been going on. So this has been the responsibility for the framework, it has been done by the framework only. Now coming to the reducer phase. So what happened in the reducer phase? So I want the expected result is like this. Expected result, because we are the developer, we know what is our requirement and what is our exact expected output should be there. So our expected result is should be like this: Hadoop comma 2 is comma 2, like that our result, expected result. So as per the developer, you should be responsible. Okay, so a comma 1, a Hadoop 1 comma 1. So the reducer phase accepts the output of shuffle and short as input. Okay, it accepts the value like key comma list of values, because as we know I have one key Hadoop and there are multiple values 1 comma 1 is there. So as per the developer, he should responsible how to write the logic and how to give the summations here. So that it will become 1 comma 1 to 2. So it will just write, I just write logic here, and it will become like this. State a summation. We have to sum of the values. Whatever the list of values we are getting, we have to sum of the values. So it's like a simple example which I am just giving to describe the phases here. So how the phases is working, like map of phase, transformation, and shorten shuffling, and reducer phase, which is known as the computation phase. Yes, so this has been completed as per the expected output we are getting here. So that should be fine. So now coming to the block versus splits. What is that? So as we know, when whenever I stored
Is it
the,
block is physical and split is logical kind of thing?
yeah, exactly. Yeah, whenever I store the data into HDFS, the data splits, or we can say divides or splits, or we can say the data is stored in terms of blocks. As a level of the HDFS, when we are talking about I just want to store the data in HDFS, that data will be stored in the HDFS in terms of blocks. So if we are talking about 2.x or 1.x, the block size should be 128 MB. So right now everyone is using the 2.x version or included a 5.x version. So there the block size is 128 MB they are dealing with. We can also configure the block size there as we have discussed in the previous session. So now coming to split. So I know splits come into picture when we are dealing with the MapReduce job. Then splits come into picture. Split is logical. It is not a physical. As we know, STFS, whatever the data we are storing, it's a physical. We can able to see and as compared to split, it's a logical, and it is not meant for the storing. It is meant for processing processing the data. So remember this point. MapReduce works with splits only. They don't know what is the block in the SDFS. Whatever the data we are fetching from the SDFS, internally the splits came into picture, and the MapReduce picks up the data from the splits only, not from the blocks. So I will show you a diagram. Let me just go into the diagram so you will be better understanding for this. So let me open the pen. So
So this
like,
maximum block size will be 128 MB only. It won't exceed that
yeah,
block.
no, it is not 128 MB only. We can extend up to, let me write here, extend up to 1 GB, the
Okay.
block size. Okay.
So that's a range, and it could be any size
Yes,
block.
exactly. That is the maximum value we can extend up to 1 GB only. In that range, we can give any values of the block size.
Okay.
Okay. So let me go ahead with the pictures. Like take an example. I have this data. So take an example like I have 200 MBs of data. I can say, okay, I have 200 MBs of data in 2.x version I'm using, but assume let's assume the block size in 2.x block size in 2.x is equal to 64 MB. It may be possible, right? Block size in 2.x is possible in 60 is equal to 64 MB. Yes, exactly. As I told, we can configure the block size up to 1 MB to 1 GB. Okay, so I'm just giving the configuration with 64 MB. So what happened? So we know if I give 64 MB here, so how many blocks will be created here? So let me create the blocks first in SDFS level. So it will create 4 blocks because 64 MB first block, 64 MB second block in SDFS level, and 64 MB in the third block in the SDFS level, and one more block 8 MB. So let me write here 64 MB first. This also 64 MB. This is also 64 MB, and remaining is the last one is the 8 MB. So let me connect with these portions like this is this. So these are the blocks in the SDFS level. Let me write here. It is at SDFS level. SDFS. Blocks create on the SDFS only. So after this, I am just worrying about the MapReduce. So the splits came into picture because the MapReduce works with splits only. So the how the splits generate there. So like see whatever the number of blocks, whatever the number of blocks there, if I have not configured the split size, if I have not configured the split size in one of the file known as mapred-site.xml, I will write it down in the somewhere. So I'm just telling mapred-site.xml. So the block size is equal to the split size is equal to the block size by default. So whatever the number of blocks is there, same number of splits should be generated. Understood? So like this is splits. Let me write here. Don't confuse this block. This is splits here. So I have not configured any split size in the mapred-site.xml, one of the configuration file. So what will happen? By default, internally in the system, whatever the split size splits block size is there, the same size of the split should be created. So I know the block size is 64 MB. So the split has also created the 64 MB here. So one split is 64 MB, second split also 64 MB, third split also create the 64 MB. Okay, and fourth split also can create the 64 MB. So I have four splits total. I have four splits. So now if I configure the split size, if I configure the split size in this mapred-site.xml, one of the file is there. I configure the split size there. Like I'm saying, I configure the split size in the backend. It will generate two, like 100 MB. We can say. So let me extend it. 100 MB of the split size. Like one split should be at 100 MB. So instead of creating four, how much it will create? Two only, because my data size is 200 MB, and it will just concatenate all data as per the framework responsibility, and it will divide this data into two splits there. So it will create two splits. But I have these splits. There is no configurations. That's why this all splits has been created as per the block size. So now coming to the mapper phase. So the number of the splits generation, the same number of mappers should be generated. If the map number of splits is 4, take an example, there the number of split is 4, generated split is 4, the same number of mappers should be generated. So there are 4 splits, so 4 mappers should be generated here. 4 mappers internally it will generate as per the number of splits. So let me write here, it is a mapper. It stands for M for mapper. I am explaining like that. M stands for mapper. So it is mapper, and it is split. We can say S1. Split S1. We can say it is split S2, and it is split S3, and this is split S4. We have 4 splits. We have, so by default, whatever the number of splits is there, the name number of mappers should be generated in the backend. This is the main concepts. So it is like that, and these are the mappers. Okay, so now till we have talked about the mappers, splits, and blocks. So after mapper, we know there's a shuffle and sort come into picture. Shuffle and sort. Take an example. This is our shuffle and sort. We can write it like S and S. Shuffle and sort. Okay, so whatever the data, whatever the output data come from the mappers, whatever the output of the mappers become the input of the sort and shuffle. Okay, so we have already seen in the example, just I have given the example of the all phases. So it is the input of these things. So I know after sort and shuffle, the reducer phase come into picture. So by default, there is only one reducer is there by default. We can increase the reducers, number of reducers. We can minimum is one only. We can extend up to number up to requirement. So by default, let me tell you. So like, see, this is our reducer here. So like this is a reducer. I have not modified anything here. So this is a reducer. So after getting the short and shuffle, what will the output coming from the short and shuffle? What are the output got from the short and shuffle will be the input of the reducers here. Okay, it will be the input of the reducers here. So what happened after the computations has been completed from the reducers, like computation has been completed from the reducers, what happened? So the output file should be generated somewhere, right? The output file where I can expect the output in some of the file, so that whatever the number of reducers there, like I have one reducer, one output file generated. Okay, if I use two reducers, two output files generated. So this is the way, this is the overall architecture, how the MapReduce works internally. So first, data come here. Second, it is placed into blocks. Third, is splits come into picture. Fourth, mappers come into picture. Fifth, start shuffle, and sixth, reducer. Okay, so this is the way we can go ahead and we can see the architectures of the MapReduce. So let me go back. to this. So now we have discussed it about the blocks and splits, and I have seen some of the splits and block. These are the completed architecture already completed about the map and reduce. Now coming to the main technical classes, like what type of technical classes we are using to create our map reduce, what you can say applications. So there are six main technical technical classes here. So what is that? First is, let me write it down here. So first is known as split derivation. Split derivation. Derivation. So we have to, as you go ahead with these things, let me go for the pictures. So first, the data is in the SDFs in terms of blocks. Okay. So first we have to split this data. Split in terms of splits only, like S1, S2, S3, S4. So how we do this? So there's a technical classes, split derivations. So for that, which class I have to call? org apache.hadoop mapreduce dot input format. So this is the one class for split derivations. Second class, key value pairs. As I told you, MapReduce works with the key value derivation. So what is that? So which class I have to call? So org.apache.hadoop.mapreduce.recordReader. So let me explain about record reader. What is that? So record reader came into picture when we are dealing with MapReduce jobs. So record reader is a framework responsibility which is responsible to convert our data into key value pairs. So this is the second derivations of technical classes. Third is mapper class. Mapper class. Okay, this needs to be extended with one of the class known as map. So what kind of technical class we have to call? Hadoop.mapreduce.mapper. So this is the class. Okay, we have to call the third class as we have seen in the diagram as well. The mapper came into picture. Now fourth is reducer. In between, because in between we have got one of the no class known as what sort and shuffle. So we are not responsible for that. So we have to skip because I'm not a developer. I don't want to any technical task for that because framework is responsible for that things. That's why I'm skipping that. Now do dot mapreduce dot reducer. So this is the fourth class. There is technical classes we have talked. Okay. So now coming to fifth class, we have after completion of these things, we have to write the data somewhere, right? The output data. So there is a node class known as key value derivation at output level. So which class I have to call? org.apache.hadoop.mapreduce.recordWriter. We have seen about the record reader. Now here record writer also come into picture for writing the data into key value pairs. Now coming to the last class, like we have taken about the input format. Now what is the output format? Like what kinds of file format you are using for getting the data? So like we can say output data storage format. Okay. Output data storage format. For that, we are calling one of the class known as org.apache.hadoop.mapreduce. Why we are calling everything mapreduce? Because we are dealing with the mapreduce jobs here. Output format. So this is the main technical six classes are here. So you are responsible for these four classes. So it's very easy. It is not no need to write remember these things because when you deal with the applications or somewhere, so you technically this class will come into picture. So as per the uses and all these things. So coming to data types in MapReduce. So as we know, for each and every tools or language, whatever we are using for the processing or some analyzation, so for each and every, there is a one data type should be they are supporting. Like we can take example C, Java, and any languages. They have its own data type. Somewhat different is there. Okay. So now coming to MapReduce data type. So MapReduce data types. So what is the data type in MapReduce first? So instead of integer, we have to write int writable here. Okay, suppose we are dealing with the integers value, so you have to write int writable, that data type. So now second is, if you are dealing with one of the string value, like my name Shabazz, your name Sohel, like that. So you're dealing with one of the string values. So instead of string one of the data type, you have to deal with text. And if you are getting any floats value here, so we have to write float writable. And if you are getting some long value here, so we have to long writable. So this is the way I can explain about the key data type in the MapReduce. Okay, so these are the basic data types which we are using. Also boolean also supported here. Boolean boolean writable, we can say. And sorry for that, it is readable. Oh, and one more data type I will tell you, that is a null writable. Suppose you are getting null values here. Okay, that is a null writable here. So these are the basic key data type we are using in the MapReduce data type. MapReduce by writing the program or applications, creation of the application MapReduce. So these are the basic data type we are using there. Now coming to the types of input format in MapReduce. What kind of input format they are using there in MapReduce? So they are supporting, like we can say input format means we are getting the data from different sources. What kind of input format, what kind of data they are supporting? So first is known as file input format. Okay, second one is known as text input format, and third one is known as key value input format, and one more fourth is known as sequence input format. This is a very useful file input format. Input format, yeah. So I'm just telling you there are lots of input formats are there. So we will deal with these four input formats here. So by default, if we are not mentioning any kinds of input format, it should be text input format here. It is text input format if we are not defining anywhere as a this what is saying file format. So it is taking the text format. If for the input, for the output as well, we are dealing with the same file input output format, text output format instead of input, key value output format, sequence file output format. So if we are not describing any file output format, by default it will take the text output format. So whatever data we are getting after analyzation, it will be in or text file only. So these are the we can say file input format or file format we are using there. So let me, okay, so I have already discussed with all everything. So programmatic, now I'm going ahead to discuss about this programmatically approach of MapReduce. Okay, so as we know, if we are dealing with one of the Java code using any tools like Eclipse or NetBeans or somewhat, so there is a driver class. One is the driver class. Driver class means which is responsible to drive whole application. So how we understand which is a driver class in Java or Eclipse? So where you are getting public, static, void, main, and inside that string of this asks if you are getting this kind of information anywhere in the code with the upper is class name, so you understand this is our driver course, driver class. So one moment. So okay, so it is known as driver class. So after this driver class, the next class came into picture, that is known as mapper class. Mapper class. So mapper class, where we are using to write the transformations as we have discussed earlier. Third one is known as the reducer class. So let me draw something here about this mapper and reducer. So I'm just saving these things here as Mapreduce. Okay, so now I'm just opening a new one. So as we have seen, this is our, let me just as this is our mapper, as we know. This is our mapper. We are getting the data from different sources. Take an example. I'm getting data from one of the local file system for SDFS file system. So it deals with the SDFS only. We are getting the data from SDFS. So let me write it here. Okay, it takes the data as a SDFS, and whatever data it will internally convert into key value pair. It takes the data from as a key value pair, and after processing our transformations from the mappers, it again process that data and place somewhere into, sorry, place that data into SDFS only. Okay, so it is taking the data, we can say it is input, and this is the output, we can say the output data. Okay, so this is our output, and again place that data into SDFS. Okay, so what will happen, they are getting the data from SDFS only, and after transformation has been completed, that data already pushed into the SDFS. This is the mapper phase. Now coming to the reducer. Let me zoom it. Okay, so now coming to the reducer. So like this is a reducer, and also we can also say the data from there, where what is the input for this data, the after shuffle and shortening, what was the output data after shuffle and short, that is the S and S, we can say output is the input of reducers, right? So let me diagram of this. We can say it is the input data, input, which is should be key comma list of values, as I have told you earlier how it is listing of values, and after completion of this, it again places the data into SDFS, because every time the storage area is the SDFS only, we are dealing with the SDFS. So that is the output, we can say. So this is the way how the mapper and reducers works, like for each and every phases. So now coming back to agenda here. So now we, these are the programmatical classes of MapReduce we have talked till now, like driver class, mapper class, and reducer class here. So now coming to the safe mode in Hadoop. As an admin purpose, you already know what is safe mode. So let me explain about the safe mode first. So safe mode in terms of what does it mean? Whenever, let me write something here, we are starting Hadoop cluster. Okay, name node is safe, name node is safe mode on. We can see, yeah, safe mode on. So it means SDFS, the storage area, is read only mode. Means we can able to read only there in HDFS. We can't able to load the data. We can't modify. We cannot able to modify the data. We cannot load the data. We cannot remove any directly from there because of name node is in safe mode. That's what this means. Means we won't be able to write or overwrite any files. Any files in HDFS. Okay, so whenever the safe mode is on, we can't able to write or modify anything, any things in the SDFS file like that. So the thing is how to check the status of safe mode. How to check the status of safe mode. So there is a command for that. SDFS TFS admin. It is a responsibility for the admin hyphen safe mode get. Get means we will get the status of the safe mode there if you use get there. Okay, so let me write this command in our Cloudera, which is the distribution which I'm using right now. So let me open the terminal here, open terminal, and I'm in the terminal. So right now I'm using Hadoop space version. If I enter, so I'm using the Hadoop 2.6.0, that is Apache distribution version, and as compared to Cloudera, it is CDS 13.0. One moment. Yeah. So the in CDH we are getting CDH 5.13.0 version I'm using as a Cloudera version, but as Apache we are using these things. So we are talking about safe mode. So now let me check the safe mode status. So SDFS TFS admin hyphen safe mode get. Get means we will get the status of the safe mode. What is the status right now of the name node? Select enter. We'll see. Okay, so right now safe mode is off. It means I can able to put the data, I can overwrite the data in the SDFS there. But whenever safe mode is on, okay, so let me do one thing, SDFS, TFS hyphen, so ls is there. I have data.csv. I just want to put this data.tsv file into our SDFS. So how we can load this data? SDFS, DFS hyphen put what we are putting here data.csv tsv in SDFS home directory, that is a root directory that we enter. So now that data has been moved to Hadoop home directory, Hadoop home directory. So now how we can see the status? We can able to check with this command. If we will get the value as a 0, it means the data the previous command what we have run that has completed. And let me check in the SDFS directory as well. So we can able to see this data.tsv there in the Hadoop SDFS home directory. So I can able to see this data, right? The data.tsv we have created right now, 13th of April, 10th of 22, something like that this time. So now let me continue. I just want to off the safe mode, and again I want to put the data into SDFS. What will happen? So let me write here in name. Second theory is turn on the safe mode. How to turn on the safe mode? So there is a command sdfs sdfs dfs admin hyphen safe mode enter. So if you use this command, what will happen? Enter means we have to write enter, and again after that writing enter, you have to press enter. So after this, what will happen? The safe mode will be on status. So let me write this code: SDFS TFS admin hyphen safe mode and we give enter here and press enter. So now I can able to see now the safe mode is on. So again, I want to check the status. Okay. So now I can able to see the safe mode is on as I told you. So now I just my requirement is now the safe mode is on. I just want to put this file underscore hive.hql into HDFS home directory. HDFS TFS hyphen put, or you can use local copy from local as well. Instead of put, I am using right now copy from local because this is a local. I can use file underscore hyphen and we are giving like this. This is the HDFS home directory, that is a root directory. Let me enter. So what will happen, we'll see. So now I'm getting some errors here. Copying from local cannot create file this thing. Copying name node is in safe mode. Name node is in safe mode, so we cannot able to write any data into HDFS. So this is the error you will get. Only you can able to read the data from HDFS whenever the safe mode, name node safe mode is on. So let me leave. How to leave means how to turn off this safe mode. HDFS admin hyphen safe mode give leave command keywords and press enter. You'll see what happened. So now the safe mode is in off state. I'm just trying the same command what I have tried earlier. This is the command and we'll see what will happen. So now I can able to copy this data into our HDFS home directory. So I can give echo $what. So I'm getting this value. Why I'm using these keywords? Because whatever the file you're loading in the Hadoop HDFS home directory or any in the directory in the HDFS, but in real time scenario, if you are working with the multi-node clusters, the clusters are too huge, and whenever you just give the command is see the directory, so lots of directory in the home directory of HDFS you can able to see, but it's not possible. It's very difficult is to find your own directory where you have fetched. So that's what for the shell scripting, if you go ahead with automate something, you have to use this command echo dollar this quotation single. So what will happen? What will the previous command I have run? That command status. If I get the status as 0, it means that is a successful command which I have run. If except 0, instead of 0, I am getting any value positive or negative or something like that, it means that command has not been successfully completed. Somewhere is it is wrong. So this is the indication of this command like that. So now I just want to check. I will let me check here in home directory. So this file should be there. So you can able to see this file right now. I am just placing at 10:26, 2 minutes ago, and 13th of Feb. It is around 301 bytes of data. Okay, so it's all about the safe mode we have talked. So now coming to the agenda. Okay, so now I have resource manager and his job history server. What is the use of this resource manager? As we know, the resource manager is a master daemon. We can say it's the master daemon for the responsible for assigning the resource or scheduling the jobs, like that, assigning the jobs and scheduling the jobs into the task data nodes or node manager we can say. But also resource manager is responsible for access the high level logs. If I'm just executing, I will tell you right here logs information. So what does it mean? if I'm executing one of the jobs in anywhere, yeah, I'm just executing one of the jobs in Mapreduce, I'm executing one of the jobs in Hive, we will see the ETL tools as well in later next session. So what will happen? Internally, that one of the job ID creation is there. So which job ID and also that logs generation is there in the backend. So that log information, why we need the logs? Because in future if some that job got stuck or that job got failed, so I have to check the logs information. So it's the high level X logs information it has in resource manager. So I can access through GUI graphical user interface is there for this logs information. So if you want to access, if you are using the Cloudera CDH, hope so you have to try with this because if you are working with the single node cluster, so with the host name, whatever the host name you are using with 8020 port number you have to give for accessing the resource manager, and from there you can able to see the logs information. Okay, so one more thing, logs information how you can check. So whenever you trigger any job in the backend in the console from Hadoop environment, so there is a job, there is a job ID created, which is unique, which is very unique. So you have to copy that job ID and you can search inside that resource manager and you can find the all tag information like that exactly graph. I will talk about later the AG tag related things. Okay, so there is a job created inside that. So it's all about the job manager, not talking about job history server. What is that? So it's a resource manager for accessing the high level jobs. For low level jobs, like I'm just executing a very low level kind of job. So for that job history server, like I'm executing one of the big big ETL tools, big ETL tools. I'm just running one of the tools, big ETL tools script, which is very low level. Okay. So for that, I can able to access the job history server and I can see the logs here. So it means low I access the low level logs information. Okay, information we can see here. We can also see these things in from GUI. So these things that job history that we are talking, and if you are working with Apache distribution or you're working with which Florida CDH or Apache, that is development things. So the with your host name with port number 19 888, you can able to access this job history server GUI. From there you can also same thing you have to do to copy the job ID which is created during the running of the job and search from this GUI graphical user interface, and you can see the informations from there. If in case of job failure, in case of job stuck is there, so like that you have to use these things for accessing the logs related things. So this is all about the job history and resource manager. Now coming to combiner. What is combiner here? Okay, combiner is also known as mini reducer. Mini reducer, why we are saying combiner is mini reducer? Because let me write something about combiner first. Combiner is one of the performance. I'm writing here performance optimization technique. Okay, so for getting the performance in MapReduce, we are using the combiner. So like everyone is writing the query in SQL, but very low, very less person know the SQL injections for getting the performance and like that. So there's lots of performance related issues we are getting. So that job, like I'm saying, I'm just triggering our job, which is taking 2 minutes, which is taking 2 minutes to complete that job. Okay, so it is taking 2 minutes of completion of that job. So what will happen? what will happen? Uh, it is a kind of performance technique. So I have to write some performance optimization. I have to do some performance optimizations from my end so that it will take less time. Within second, it should complete. So that's why to avoid the execution more high, we can say seek time of response time with high response time. It's very less. It is low latency. Should be like that. So that is why combiner is a performance optimization technique in MapReduce. Okay, so by using combiner at each and every mapper output level, reduction of data happens. Okay, so what is saying? What were the number of mappers? Okay, so let me open one of that images. Like I have one mapper here. If I have one mapper generation here, so I have one combiner. If I have two mappers, I have two combiner. If I have one mapper, I have one combiner. If I have two mappers, two combiner is there. So it is combined with the mappers only because I said it is mini reducers. So it comes before the reducers into the picture. Then later reducer, the main reducer, it come later combiner. So reducer come into picture, combiner come into picture after the mappers for the performance technique. Okay, so let me share this info again. So these are all overall about the combiners. So this is the optimization technique. We can just aware of these combiners like optimization technique in MapReduce. This is overall about the combiner. So now compression technique in MapReduce, like I'm getting data from different sources from the client's data. So how to before loading that data into SDA like I have 200 PBs of data here. Take an example, I have 12 PBs. So instead of loading 200 PBs, can we compress this data before loading this data into SDFS? What will happen? We can able to, when I compress this data, somewhat we are saving the memory here. Like take an example, in our Windows, I have 5 GB, 9 GBs of data, 9 GBs of data. If I compress with one of the file known as RAR, okay, like RAR I'm using, so it becomes like up to 5 to 6 GB only after compression. So I am reducing how many size around 3 to 4 GBs of data. So like that here compression technique is there in MapReduce. So also we can use. So there's lots of compression technique in MapReduce. Around three techniques we have. I will tell you. So let me erase it first. So there is a one technique is known as Z-zip codec. Second is B-zip codec, and third one is snappy codec. So this is the three techniques we have. So for the compression techniques, so by default it is disabled. This compression technique by default it is disabled. So we have to enable these compression techniques by using one of the files known as, let me write here, mapred-site.xml. So whatever I am saying, this configuration related things, it is not responsible for the developer. So just I am giving the overview which file I have to configure. It is the responsible for the admin responsibility to enable the compression technique, to disable the compression technique, these things. So these things we have to enable this, like I'm using this codec uh, or BZ codec or snappy codec. So these things we have to enable in these files only. So I can and one more thing, this compression technique can be depend on the phase. You want to be on mapper phase, you want to be on reducer phase, you want to be on input level, or you want to be on output level. So everything depends upon your requirement, at what phases you want to compress this data, not whole data at mapper and reducer like that. We can't go ahead like that. We can phase by phase we can compress it. So this is the compression technique in MapReduce. Now coming to performance optimization, this is a very important topic, performance optimization. In every interview they ask about the performance tuning only. So what about the performance optimizations here? First I have seen combiner. If you use combiner in the MapReduce applications, this gives the better performance as compared to the earlier. Second is compression technique. If you use a compression technique, so there's a wastage of memory will be reduced. So we can go ahead with the compression technique. And third one is the number of increased number of mappers. As I told you, if I am dealing with a huge amount of data, but the thing is, I have only one mapper, so all the mapper is responsible for that huge amount of data. So there is no parallelism process is there. So if we increase that number of reducers, so what will happen in that the data should be distributed to each mappers. So at the same time, like one mapper is taking to process the 200 terabytes of data in 1 hour. Like take an example, 200 terabyte of data processed in 1 hour, one reducer. If I distribute if I distribute, increase the number of mappers to 4, and I told one mapper, one reducer will take to process the data within 15 minutes, like to 200 petabytes of data I have, so I can say 50 petabytes of data, it is taking 2 minutes, 5 minutes, so like that, take 5 minutes. So what will happen? All the four mappers should take 5 minutes to process 50 TBs of data. So we are expecting the result in 5 minutes only because it is a parallel process. It's a parallel fashion. So that's why increase the number of mapper. Sorry, not mapper. It is a reducer. Okay, it is a number of reducers. So it is also a performance technique in Mapreduce. So